All right, welcome to day 4 of Mrs. Cucci's College Now Pre-Calculus class. We are on file R.4 factoring, so please open up that file and be prepared to take notes. All right, so what we're going to be doing today is we're going to be reviewing factoring. Again, you've been factoring since about 8th or 9th grade, so this should be nothing new. There may be a new topic here and there. We will be spending about a day and a half on factoring and reviewing, making sure that you guys are very good at factoring because it does become very important. Next page. Okay, by the end of this lesson, you will be able to factor polynomials by removing a common factor, or GCF, factor polynomials by grouping, factor trinomials of the type x squared plus bx plus c, factor trinomials of the type ax squared plus bx plus c. That should say c, I apologize. And using FOIL method and the regrouping or grouping method. Okay, next page. All right, when factoring, you always want to look for a GCF if possible. So that's the greatest common factor, a factor that can be taken out of every single term. So we look at our terms. We have 15, 10x, and 5x squared. And we're looking for a number that goes into 15, 10, and 5. And what should be popping into your head right away is 5. The next thing you want to look for is a variable, if you can take a variable out. If you look at our first term, it's 15. It doesn't contain a variable, so we can't pull a variable out. Each term doesn't include one. So we're just going to pull out the 5. Now, the way that we get what goes into the parentheses is by taking our GCF and dividing each piece by it, each term by it. So 15 divided by 5 is 3 plus 2x minus x squared. And we have our GCF pulled out. Okay? So that's factoring out a GCF. All right, next page. All right, so we're going to give this one a shot. So again, you're looking at the coefficients first, and then the variables to see what you can pull out. 12x squared, y squared, minus 20x cubed, y. So we're going to look at 12 and 20, and we're going to think about what we can possibly take out. So what's the largest number that can be factored out of 12 and 20? Well, we know 2 comes out, but is that big enough? 3 goes into 12, but not 20. 4 goes into 12, and it goes into 20. Is there anything bigger? Well, 5, no. 6, no. 7, 8, 9, nope. So it looks like we're dealing with 4. So we're going to pull out a 4. All right, so now let's go to the variables. We have an x squared and an x cubed. So how many x's can we take out? We can take out 2 of them. So we're going to pull out an x squared. And now for the y's, y squared and y. Well, it looks like we can take out a y. So you're taking the smaller exponent is what you're doing for variables. So now we figure out what goes in those parentheses by dividing out. And it looks like what we're left with is 3y and 5x. So 4x squared y times 3y minus 5x. Next page. Okay, so factor by grouping. Some polynomials, pairs of terms have a common binomial factor that can be removed in a process called factor by grouping. Now this is a little bit different process than what we learned last year, so please pay attention. Well, maybe this one won't be. Okay, so x cubed plus 3x squared minus 5x minus 15. So the first thing that should be jumping out at you is it has 4 terms. And we know what to do with this. We've done this before. When we have those 4 terms, we're going to take it, and we're going to take the first 2, and we're going to take the second 2. Keep in mind that you have to include that negative 5x. That negative goes with the 5x. All right, so our next step is to pull out the GCF for the first half. So looking at it, we have x cubed and x squared. We take out an x squared, which leaves us x plus 3. And remember that x plus 3 is important. We want to see this twice. Okay, so what do I have to pull out of negative 5x minus 15 in order to get the x plus 3? And that's going to be a negative 5. Okay, so now you've pulled out your GCFs. Next step is you keep what they have in common. There's that x plus 3. And then you have what they have out front, x squared minus 5. So x squared minus 5, the quantity x squared minus 5 times the quantity x plus 3, and that's factored. So hopefully you remember factor by grouping. We did a lot of factor by grouping last year. Okay, next page. Trinomials of the type x squared plus bx plus c. Now this is straightforward trinomial factoring, okay? X squared plus 5x plus 6. So what you're doing is you're looking for two numbers that multiply to be 6 and add to be 5. So you start by putting your two sets of parentheses. You know you're going to have x and an x. This sign tells you if your signs are going to be the same or different. And because it's plus, it means they're going to be the same. So you look here. What are they both going to be? They're both going to be plus. Okay, so two numbers that multiply to be 6 and add to be 5. Well, here are our options. 2 and 3, 6 and 1. Which one of those adds to be 5? That's our 2 and 3. Okay? Quantity x plus 2 times the quantity x plus 3. Next page. Let's try another one. Okay, x to the 4th minus 6x cubed plus 8x squared. So now this one looks a little bit different, doesn't it? We've got our x to the 4th and we have our x squared in the front and the back, right? But that's not really going to change it very much. The only way that's going to look different is instead of having an x and an x, you're going to have a x squared and an x squared, right? Because x squared times x squared is x to the 4th. And then on the end, because we want it to be x squared, you're going to have x and an x. So we just need to figure out these values here, okay? So again, we look at the sign. It's a plus. That means we're going to look here. It's going to be minus, minus. Numbers that multiply to be 8, that add to be 6. 8 and 1, 4 and 2. Well, 4 and 2 seems like the obvious. 4 and 2. So now how can we make sure that we're 100% correct? We can always go back and FOIL this out to make sure that we were right. And you should do that. Okay, so let's run through a check. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 2x is positive 8x squared. Combine our like terms in the center, x to the 4th minus 6x cubed plus 8x squared. And that checks back to our original. Okay, so it's a very good idea to always check to make sure that you've done it right. There's absolutely no reason to get these wrong if you can make sure that you are correct. All right, next page. Okay, let's try another one. X squared plus xy minus 12y squared. We're going to start the same way. Two sets of parentheses. I know because my first term is x squared, I'm going to start with x and x. If I look here, my signs are going to be different, so plus and minus. And because I have that y squared on the end, I know I'm going to have a y. So what I'm looking for is these terms here, okay, these coefficients. So two numbers that multiply to be negative 12 and add to be a positive 1. So let's look at that. Negative 12 adds to be a positive 1. So we could do 4 and 3. One of those would have to be negative, and since we want it to be add to be a positive 1, we do plus and minus, right? We could do 6 and 2. Well, that's not going to add to be a positive 1, so that's not going to work. Or 12 and 1, that's not going to add, right? So it's positive 4, negative 3. X plus 4y times x minus 3y. And if it helps you to make these little T-charts, go ahead and do that. Next page. Okay, so trinomials of the type ax squared plus bx plus c. So having a leading coefficient greater than 1. Now, a lot of times this just means that you're going to have to do some trial and error. There's nothing wrong with trial and error. It just means the first time you don't get it right, you have to keep trying. Okay, so 3x squared minus 10x minus 8. Well, this should be jumping out at me, 3. We know 3 is a prime number. There's only 2 numbers that multiply to get 3, and that's 3 and 1, right? So that piece should be very simple for me. I know it's going to be 3x and x, okay? My other concern is this 8. I'm looking for factors of 8. Now, we can't use that same rule, multiply to be 8, add to be 10. That's not going to work, okay? Because we have that coefficient of 3 out front. So what we have to do is we have to try something. So if I think about my factors of 8, I know I have 4 and 2. I have 8 and 1. So let's try 4 and 2. I'm just going to throw something in, okay? Notice I'm not putting in the signs yet, and there's a reason for that. So what I'm going to do is I'm going to FOIL this through to get an idea of what I might have. So I've got 3x times x is 3x squared. 3x times 2 is 6x. 4 times x is 4x. And 4 times 2 is 8. So looking at those terms, could I get a 10? That's what I'm thinking to myself, okay? Could I get a 10? And remember that these signs have to be plus and minus. We don't know which way they're going to work. So we want to throw something in to see if we can get that. So this would be 3x squared minus 6x plus 4x minus 8. Would that give us a negative 10x? No, it wouldn't. So we have to try something else. Okay? So what if I switched places, 2 and 4? Well, let's try again. 3x times x is 3x squared. 3x times negative 4 is negative 12x. Positive 2 times x is plus 2x, and then 2 times negative 4 is negative 8. Is that going to give us that negative 10? Yes, it is. So there is our solution, okay? So I had to do it twice. I didn't get it right the first time, and that's okay. You just have to continue pushing forward and trying something else. Okay, next page. So let's try another one. We have 12x squared plus 15x plus 10. All right, so first thing I'm going to do is set that up. I know my signs are going to be plus plus because look what's here, right? That's important. Okay, so now I'm going to start and think about this another way. Now, I set these up right away. I was too fast in doing that. I shouldn't have done that. I want you to think about why I shouldn't have done that. Look at my polynomial. What do you notice about my coefficients? What do you notice about those coefficients? 12, 15, and 10. Do you notice anything about them? Okay, so they don't have a GCF. So what we can do is we can try and factor this. Now, remember, not everything is always factorable, and we have to keep that in mind. We can do this a million times and still not come up with anything. And honestly, what I think I did is I put 2 problems together that I didn't mean to put together. So we are actually going to take a step away from this one and move on to the next one. Okay, so the grouping method or the AC method, this is new. You guys have not learned this before, so we're going to give this one a shot. So to factor ax squared plus bx plus c, where a does not equal 1 using the grouping method, first thing we're going to do is factor out the GCF. We're going to multiply the leading coefficient a and the constant c. We're going to try and factor the product AC so that the sum of the factors is b. That is, find the integers p and q such that p times q equals a times c and p plus q equals b. Split the middle term, that is, write it as a sum using the factors found in step 3, and factor by grouping. So let's give it a shot. Okay, so factor 12x cubed plus 10x squared minus 8x. So we're going to try this method. So the first thing we're going to do is we're going to look for a GCF. 12x cubed plus 10x squared minus 8x. So 12, 10, and 8, what goes into all of those is going to be a 2. And we also have an x. So we're going to pull that out and see what that gives us. So now we have this. So the piece that we're going to be looking for is into factoring is this piece here. So now we're going to take a look at that piece, and we're going to multiply the leading coefficient and the constant together. So our leading coefficient is 6. Our constant is negative 4. So 6 times negative 4 is negative 24. Okay. So now what we're going to do is we're going to consider that 6x squared plus 5x minus 4. And we're going to take what we just found, that negative 24, and we're going to try and factor it so that we can get my middle term. Okay? So think about negative 24. How can we factor it so that I can get a 5? All right? So let's start running through it. 1 and negative 24 won't work. Neither will negative 1 and 24. 2 and negative 12 won't work. Well, neither will, because remember, this is our goal, neither will negative 2 and 12. 3 and negative 8, well, that gives us a negative 5. What about negative 3 and 8? That'll work, okay? So negative 3 and 8 is what we wanted to find. So here's what we're going to look at. We know that 5x is the same thing as negative 3x plus 8x. That's going to be important to us, okay? So here's what we do. We take this information right here, okay? I'll change colors so you can see where this starts. We have our 6x squared, right, from our original, minus 3x plus 8. So all we did is we took this and changed it, minus 4. Okay? Now, we factor by grouping. You guys know how to do this. You take the first half and the second half. You pull out your GCF, 3x, 2x minus 1, and we pull out a 4, 2x minus 1. So we get 3x plus 4, 2x minus 1, right? But don't forget what we had out front is we had that 2x originally that we pulled out. Okay, so here is our factored form of this. Okay, I know that's tricky because it's the first time you've seen it. We're going to do a lot more examples with that. So here's, again, what you do. You pull out that GCF, okay, GCF. You find the product of A and C. You find the factors that add up to the center term B. You break it apart. You factor by grouping. And then you tack on your GCF. Okay, so again, we're going to do more than one of these. I know this is new and difficult, so we will practice quite a bit with this. All right, next page. Okay, so special factoring, you guys know how to do this. This is the difference of two perfect squares. Quick and easy, x squared minus 16, which is just x plus 4, x minus 4. No big deal there. You guys have been doing that forever. Okay, so 9a squared minus 25. Well, again, difference of two perfect squares. 3a minus 5, 3a plus 5. The only difference is you have a coefficient on that first variable. X to the fourth minus 6y to the fourth. So again, you're going to pull out a GCF, which is our 6, x to the fourth minus y to the fourth. And then difference of two perfect squares, right? We know the square root of x to the fourth is x squared. So x squared plus y squared, x squared minus y squared. Okay, so the rules for squaring binomials can be reversed to factor trinomials. And again, we have done this, okay? This is just foiling. So you guys know how this works out. This is just a general version of what you already know. Okay, so very quickly, we can factor this. X squared plus 8x plus 16. If I look back here, x squared plus 8x plus 16, we know how to factor this. Right? X plus, multiplies to be 16, adds to be 8, 4, 4. Nice pretty way to write it. X plus 4, quantity squared. We're almost done. I know I'm just over 20 minutes. We have one more example, I believe. Maybe two. 25y squared minus 30y plus 9. Okay, so again, let's look at what we have. Okay, so 25y squared minus 30y plus 9. We are actually going to stop here, and I'm going to start a new video because I am over my time with the rest of this lesson. So we're going to stop here. We'll practice up to here tomorrow, and then I'll have the finish of this lesson for tomorrow night. Okay, thank you.